So this talk is Kubernetes-style APIs of the future. The Kubernetes resource model is coming to an API near you. I'm Daniel Smith. I've been a developer on GKE and Kubernetes since before Kubernetes was open source, so a very long time. Yeah, so let's get right into it. So Kubernetes has always been API focused. Back at the very beginning, before we had any frameworks, we made an API. We needed to get data between control plane, kubelets. We had to give users a way to interact with it, and everything went through the API. Everything was on an equal footing. We started out with just random usage of the Go JSON marshalling library. And over time, we evolved to make it easy for people and systems to work together. We ended up building an API platform. And whenever I say that, I feel like I should follow up with the word oops. But is it really a mistake? I think the reasons that we did this were good ones. We didn't make a mistake. We needed different things from our APIs than were on offer from the various API systems out there. So let's talk a little bit about APIs. I don't know if you've ever made a hobby website or anything like that. I have, and you're writing a back end, you're writing a front end, you add an API because you need to do this little thing, and you add another one because you need to do another little thing. Here I've got a user adding a bunch of RAM to their shopping cart and then attempting to charge their card for it. I've done this sort of thing before. It doesn't scale because you've got some handcrafted artisanal server-side code that is lovingly putting together a JSON response object. And that's great until like a new person looks at your code and they're like, I have to go read your server code to know what sort of client to write. So this is sort of the first thing. Well, maybe I'm the only one that's done this, but this is sort of the first thing you do when you try to solve this problem. So then you start to get smart, and you're like, well, what if my API is actually about the existence of some resource or its state, and I can model the resource as like a first-class citizen. So then you come up with something like REST. So for my purposes here, REST is this idea that your operation should match up with the HTTP verb that you're using. And CRUD is the idea that you support create, read, update, and delete operations. Yeah, so that gets us a little bit of the way towards an understandable API system. This is sort of like the API version of object-oriented programming. But it doesn't quite go far enough. So here I have an example of gRPC, which, don't hear me wrong, I like gRPC, it's a great system. But if you want to sort of reproduce the system that Kubernetes APIs use, you have to make an awful lot of code. For example, here you've got a message that describes the resource, and then you have to make a separate message for the create request and the create response. And you have to do this for every verb that you want to support. And when you're done, you have a bunch of code, and maybe your programmers are going to do it consistently, maybe they're not. And you can generate documentation, but that sort of works for humans, although humans have to go read it. It doesn't work for machines. If you want machines to call all of your APIs in the same way, it doesn't work for them. So yeah, I have to write a lot of stuff just to get a consistent API. Let's talk a little bit more about what API systems do. They're basically opinions, very strong opinions about how you get stuff between clients and servers. So I have a little diagram here of how, the rough flow. You start with some in-memory stuff, you do some manipulation to it, and end up with something you can send over a network. The server does some computation. Hopefully there's no side effects, or maybe you want the side effects, and then it sends back a response. So you can summarize this as an API call has some amount of data, some action, and there's some transmission layer. And I've drawn the data and the action in the same layer here because they're actually fungible, right? You can have one API request with a bajillion options, or a ton of different API requests with like no options at all. So it's really you can shuffle the stuff into one bucket or the other. It accomplishes the same thing. So an API system is like some sort of specification telling you how to do each of these things. And the Kubernetes resource model goes beyond just that specification. It's a specific sort of a specific way for you to do each of those items, right? So under the Kubernetes API system, we require a standardized data structure, standardized methods, and you end up with a standard resource. And again, this is important because we want not just humans, but machines to use your resources. Yeah, so we go beyond object-oriented. We are requiring it's like being, like object-oriented programming is like, here's you phrase your problem in terms of objects to which you can perform actions, right? Well, we say you can have as many objects as you want, but they must be structured, their data must be structured in this way, and they must support these actions, so you don't get to choose. So it's actually more restrictive. So why is it more restrictive? I want to argue that a lot of, if not all of, modern software engineering practices are actually about complexity management. And so, for example, take your source control system. That's about managing the complexity of having lots of lines of code. Object-oriented programming is about managing the complexity of having lots of code. There's just about everything like functional programming, immutable objects. This is about managing the complexity of your code as it's in motion. But what about API systems? Because they have a lot of complexity also. So I want to talk about two different kinds of complexity. The first is the operational complexity. Like, what are the different things that you can do in your system? So for example, just to use the Kubernetes API as an example, we have 6 verbs that we support that we more or less require. And we have a bunch of different API objects. So we have pods, replica sets, deployments, services. If we document each of these separately, we have a bunch of users that have to go read them, right? If you're a user using our system, you want to figure out what a various, I've got a pod here and I want to read it. Do you go read the documentation for this pod? I mean, that's great, but if you repeat it for every verb for every object, that's a lot of reading, right? We can solve it with documentation, sort of, but how many of you think programmers are really great at writing documentation? So how does the Kubernetes resource model address this problem? We address it by restricting the possibilities. We document a standard metadata. You're not allowed to have a non-standard metadata. You won't be compatible with the ecosystem. We document standard verbs. You must, your verbs on your resource must work the same as the verbs on any other resource. You're not allowed to have for example, an update method that is just a random grab bag of fields that you can update. It is the same object structure as the thing that you send to the post method. So you do this, and now a user that understands how to post a pod also understands how to post a deployment. The only thing they have to learn is the contents of the deployment object. Or if I know how to post a replica set, I also know how to put a replica set, because the difference is just a different HTTP verb. The body of this request is the same. And if I learn how to put one thing, I've learned how to put another thing, because optimistic concurrency works the same across all of our objects and methods. So hopefully this leads to a bunch of happy users. I can say this another way. We've got all this stuff in our system: pods, nodes, services, RBAC rules. I've got my custom resource, which is essential to the operation of your cluster, but your custom resource, which is pretty nice to have, and their custom resource is, well, we're just running it because management wants us to. But you look at that, that's a lot of stuff you have to learn. We have 6 verbs. Right, I've drawn 6 verbs there, but that 6 is really a stand-in for the average number of operations per resource type. So you think of this as m times n. This is polynomial complexity. And that's not good when you want a human to understand your system. Kubernetes resource model turns this into 6 operations and n things. It's much more understandable for humans. The second part of complexity that I wanted to talk about is state complexity. This is like your API, like in the abstract, you read your APIs. It's a system of calls and documents. But when it's running, when it's in motion, you have a bunch of. You don't have just one node. You have a bunch of nodes. You don't have just one pod. You have tons of pods, and so you've got the complexity that comes in from having lots of different items in your system, which can be in lots of different states. Right. So if you've got one pod and one node, and they can each be happy or sad, you've got 4 states, right? And 4 states doesn't seem so bad. But if you think about it, if you've got a node and it can be in one of 5 states, and you've got another node which can be in one of 5 states, and you've got n of these things, that comes out to 5 to the n, which is an awful lot of states to think about. And the way the Kubernetes API system, the resource model, addresses this problem is by splitting it into small pieces. And we have the controller mechanism. So we write a controller. The controller understands only one thing, and it doesn't have to understand the rest of the system. It treats the rest of the system as a black box, and it just tries to drive this one thing into the correct state. You can think of this as the controller is substituting that multiplication for an addition, and hopefully we turn those 5 to the n states into n times 5 states, which is much more comprehensible. So why is this possible? Or why is it difficult in other API systems is maybe a better question. We have this concept in the Kubernetes API system that you manage your resources declaratively. So we have this command, kubectl apply right now. It lets you decide which parts of your resource you want to manage, and you just don't mention the rest of them. And it's free for the controllers in the system to manage them for you. So let's see. The example I have earlier in the slide deck is a deployment managing the replicas of your. The horizontal pod autoscaler manages the replicas. You set the image of your deployment. We can't have it such that when you change the image, you accidentally blow away the replicas field. That's no good. So it has to work for both controllers and humans. So there's a nice side effect, if you remember this slide, which is if you're a human, apply is sort of basically a do what I mean command. If you're just tweaking things in the system, you basically only have to learn one operation, which is even nicer. So yeah, here's my diagram. kubectl apply. I set the image of my deployment. Horizontal pod autoscaler patches just that one field. And when I change it, I don't mess with what the robot is doing. And the Kubernetes resource model, because it's standardized, because we have these restrictions on how you can format your data, makes this possible. So, why will you see APIs following the Kubernetes resource model in the future? I think it's because a lot of real-world systems are a good fit for the Kubernetes resource model. I can imagine many virtual resources, like, of course, the objects in the Kubernetes system, which is the reason why the API system exists in the first place. Virtual machines, load balancers, database endpoints, service meshes, anything you can imagine. Kubernetes clusters. I can imagine managing physical resources this way, network switches, routers. Any system where you've got a bunch of things that can be in different states. Being even more speculative, I can imagine doing Internet of Things devices with this sort of system, right? Like if I'm writing a program to run over my light bulbs in my house, I definitely don't want a big tangled nest of if statements. I want to write controllers to manage things and have it be shardable. And when I install a new light bulb in my kitchen, I don't want the rest of my carefully crafted system to fall apart. Ask yourself, can you keep your system's entire state diagram in your head all at the same time? I mean, if you have more than 3 things in your system, I think the answer is probably no. That's just not humanly possible. I mean, if your state chart has like 500 spots in it, and you add a new state to the system, that's 500 places you have to go audit for bugs, because you've changed the meaning of the system, which is what I just said. So the Kubernetes resource model allows you to effectively manage the complexity of your API ecosystem. And I think that is why you will encounter these APIs in the future. Thank you. This was I think I have time for questions. I thought I had a lot of slides, and we went through those pretty quick. There's a mic set up over there.
Actually, I fully agree with you. I like the Kubernetes model. So I'm wondering, is there any other Google products or open source products coming up that actually follow your advice? Or is it more like you would ask to follow your advice so that you can then explain at Google that others are doing it already?
I don't know what I'm at liberty to say. I think the answer to that is wait and see.
Okay. Ping, ping, ping. So okay, so you've convinced me, like, you know, I'm all on board with this Kubernetes thing. Like, what next, right? Like, what do I do with that?
Yeah, so I hope to, I have to say it's a little hard to use our system right now. It's a little hard to write new APIs. So I really hope in the coming months to work on that. I'm working on making apply general and usable for everybody right now, and the next step for me after that is to make the control plane really a standalone product.
So I'd like to follow up on that. I'm actually doing this. I'm building a control plane for a traditional IaaS system using this kind of technology, using aggregated API servers with types built in. I think it's working pretty well. There was a project mentioned at the previous KubeCon about a generator for API servers. I haven't heard anything about that since then. What's the status on that?
I think you're talking about KubeBuilder, perhaps?
Maybe, I don't remember.
Yeah, KubeBuilder is still a thing. My colleague Phil has been working on it. I've been heads down on apply, so I haven't dug into it too much yet. But yeah, I really plan to make even if we were doing it just for ourselves, we would have to do this work. But I really plan to make the whole life cycle of building an API convenient for a developer. You know, like right now we have these types.go files. You declare your API types with specially crafted Go structs. So yeah, I want to make this into a real language, and we're starting that as part of the apply changes. But yeah, I expect I have grand visions of like a pathway that you write this, you get a CRD if you want to use a CRD, or you get the generators and stuff if you want to make a aggregated API server. Yeah.
Will you call it API Rails?
Will I call it API Rails? You know, I'll file that as a suggestion.
Hey, thanks for the talk. Do you want to talk about sub-resources? I didn't hear that at all.
Yeah, sure. So in the Kubernetes style, there's sort of 2 uses for sub-resources. And if you've seen our HTTP paths, you've got like a namespace and a resource and like the name of the resource. And then sometimes after that, you'll see another word, which is a sub-resource. And so there's 2 reasons for a sub-resource to exist. The first reason, the good reason for a sub-resource to exist is that it enables polymorphism. So we have this concept of a scale resource. So we could teach horizontal pod autoscaler to apply to everything or patch everything that has a scale, which would be great, but some people don't call the relevant field replicas. So instead, we've made this polymorphic resource that sort of converts the relevant field, which is like a replica count and a selector, I think, into a standardized format. So HPA can now work against anything that has a scale subresource. So that's like the first and good reason for a subresource to exist. The second and less good reason for a subresource to exist is that it's a way to break the glass. So you can use this like our pods support the exec option. Like there's no good way to phrase that in a declarative format. So we have a sub-resource. You can do whatever you want with it. It's a break the glass in case of emergency. So we have a few things like that, but those things are you can't really reuse them with machines. Like you gotta understand each one independently. There's no generic way to make that work.
I was wondering if you could say something about like imperative operations in the Kubernetes resource model, because like sometimes you want to do something that's like really boils down to a command. Like you have a etcd operator, for example, and you want to say take a backup. And so I was wondering like what people are doing today to express operations that are kind of fundamentally imperative using the declarative model that Kubernetes uses.
Yeah, that's a great question. So there's multiple ways that you can approach this, and some of them are good and some of them are not so good. You can have like, and I've seen people do this and it's not really pretty. You can have like you've got a declarative operation like open the doors, and you phrase that in a declarative object as like open the doors equals false or true. That's not really a good way to do it. There's ways you can sort of turn an imperative operation into a declarative one, like door openings count, so like or etcd backup count. And when you want a new backup, you increment this count, and then you can wait for the controller that's actually doing the backups to do the backup and then increment its corresponding count in the status. So that's maybe one way that's a little bit better. And in the worst case, I honestly probably would prefer to see a sub-resource over like shoehorning a fundamentally imperative operation into a declarative data format, if that makes sense.
Thanks.
No. Oh. Use the mic.
Taking a backup is a relatively easy one, right? Because you can say, make me a backup that is a backup of that. It's more like this exec thing is, I think, a little harder operation. Yeah. You can say, make a new, just like you can say, make me a new pod, you can say, make me a new backup. And by the way, the spec of this backup says it's a backup of that.
Yeah, that's a great point. That's another way to solve the problem is to like model the operation itself as an entire object, and then you get the whole life cycle there. You create a backup object, and this is the thing, and then you wait for the status operation to get filled in. That's another way to model it.
Hi. Can you talk a little bit about the difference between the spec and the status, and why is status a sub-resource?
Yes. So I think there's parts of the Kubernetes API system that are sort of mandatory, and they're mandatory because they affect whether things are interoperable or not, like the metadata, for example. And then there's parts that are just a good idea. And I would say the spec and status distinction is one of those things that is tending towards it's a good idea category. Because if you look, not all resources have a spec and status, and some are sort of fundamentally completely status, like the node object is close, if not completely status. And it's a little weird to have like an arbitrary spec, and like if it doesn't make sense. But specifically, why is status served as a sub-resource? And that is for that is actually like there's technical reasons. Like we wanted to reduce the contention on a resource. If you're a controller writing status, you don't want to have a bunch of optimistic concurrency locking conflicts because somebody else is updating the spec. And well, actually the problem happens more often the other way. Like you're trying to update the spec and you keep getting beaten by a controller which is updating status like continuously. So we split them into separate resources, I mean, with the goal of eventually like actually routing them into different places in the back end, although that hasn't happened yet. But yeah, the idea is the server at least can do retries on your behalf. So you at least get fewer optimistic concurrency conflicts.
Thanks.
Follow-up a question on that, because I never really quite understood this. So if a controller updates the status, does that update the resource version of the whole object?
Yes, it does.
So wouldn't that cause a conflict then?
Yeah, if you're using the patch command,
Well, that's another. Well, no,
yeah.
yes, that would still update the resource version.
yes, it does update the resource version. But if you're using the patch command, the server can do the retries for you.
Okay, right. If the guy who doesn't want to suffer is using a patch, then he doesn't suffer.
Yeah. Cool. Any other questions? This is great. Yeah, I had a lot of slides. I thought I was gonna, thought I really had to hurry there, but it seems like we did okay. All right. Well, thank you very much.